Alright, so reviewing a couple more sections today. 5.3, 5.4. So 5.3 was the side angle side. So just remember that if you had, you have all these different angles and sides, that if you're going to do side angle side, it has to go in order in the two triangles, that the sides are congruent and then the angles are congruent. It needs to, this angle that is used is called the included angle. It's the angle that's between the two sides. It's another way to think of it. Okay. And so most of your problems today, the first two decide whether there's enough information given to prove the angles or the triangles are congruent by side angle side. And so remember, on those, you're allowed to make conclusions. So, we've used this, at least I have. Oh, that's not good. The two really conclusions just by looking at a picture, not conclusions because you were given something, is that that side is congruent to itself because of reflexive, or these two angles are congruent because of vertical angles. So when it says, is there enough information, you're allowed to say, well, that side's congruent even if it's not marked in the picture because it's reflexive. And then that those angles are congruent because they're vertical angles. And if that helps you with the problem, fantastic, yes, they're congruent. If it doesn't, then no, they're not. Okay, so just remember, it has to go in order. And so then the next two problems are going to say, use the given information to name two congruent triangles. And so you're just looking for a side angle side within the problem. I will tell you that on one of them, you need to look at the picture and say, and deal with the fact that there's triangles that are inside of a circle. That, remember that a radius, any point from the center of the circle to the edge, is going to have the same length. So just keep that in mind. Okay? All right. So let's look at a proof. So if we were given AB is congruent to CD, and let's say AB is parallel to DC, prove triangle ABC is congruent to triangle CDB. Okay, so step one, write the given. And then let's label the picture. If you want to label them parallel, you can do that too. So then step 2, make conclusions about the given. So AB being parallel means we're going to have alternate interior angles. That's where you want your brain to go. So angle ABD, this one right here, and angle BDC are congruent, so this one here, alternate interior angles congruent. So I did my conclusion from the given. I don't have any more information from the given. So now I need to look at the picture. And so typically we're going to have reflexive or vertical angles, so there's really no vertical angles, so I can say that DB is congruent to DB. Reflexive. So remember, anything when you have triangles that are next to each other, butted up against each other, reflexive is going to be there a lot. Okay, so here's my side, angle, side, side, angle, side. So triangle ABC. Why did I put ABC? Should have put ABD. That wasn't very smart of me. Is congruent to triangle CDB by side, angle, side. So it is in a different order, but you can, the reflexive part, you can see the BD and DB, like they're in the same triangle. So whenever you see two of the same letters, that's typically going to mean that you have a reflexive property somewhere. Okay? All right. So you'll have one proof, last problem. Does talk about bisecting. So remember, bisect means cut in half, and so your conclusion is that either side of whatever's being bisected is congruent. Okay, but should be a fairly quick proof for you. I think it's 1, 2, 3, 4, 5 steps. Okay, all right, have a great rest of your day. Good. Oh wait, I didn't talk about 5.4. Okay, so that's 5.3. 5.4 was equilateral and isosceles triangles. So the big thing with equilateral, there's not a whole lot to really go over, but when you have an equilateral triangle, you have an equiangular triangle, and the angles equal 60 degrees. If they're all the same, it's essentially 180 divided by 3 is 60. That's really all there is for equilateral. The big thing with isosceles is, number one, that you remember that an isosceles triangle means that two sides are congruent. But if we have an isosceles triangle, then we can conclude that the angles opposite them are congruent. And then we had a converse to that theorem that said if the angles are congruent, then the sides across from them are congruent. Okay, and so this was called the base angle theorem. And then this one was the converse to the base angle theorem. Okay, so let's look at one problem. So the first thing that I kind of notice on this one is like this triangle on the left. If all the angles are the same, well, then all the sides are the same. So 8y equals 40. Fairly simple. So, if the sides are the same, that would mean that this side down, the kind of the diagonal one, is also 40. So therefore, if I look at this, like I pull out like this triangle here, that's already marked 40, and then I kind of made the conclusion that that one is 40. And since those two sides are the same, then those two angles are the same. That's my x angle. So I don't have any other information yet. So, but if I knew this one up here at the top, then I could subtract from 180 and then just divide by 2 because they're the same. And so I would argue that I do know some information. Like if I kind of extended this up, this triangle over here to the left is all the angles are the same. So I do know that that one is 60 degrees. Because if all the angles are the same, then they have to be 60. So then I can do 180 minus 60 is 120, because those are vertical angles. Okay. So if it's kind of going like backwards, but if I did 180 minus 120, I go back to 60. That should make sense. That means that the two red angles have to both, like they have to add up to 60. So if I just did 60 divided by 2 is 30, then each one of those is 30, but we just want to know what x is. Okay, so there's a little layered problem there to kind of combine the equilateral, equiangular, and isosceles. So let me see. Yeah, there'll be a couple similar to that, a couple easier ones like also. Okay. All right. So have a great Friday. Like I said before, it's just problems 1 through 6 on both worksheets, so nothing too crazy. Remember, we will have a test next Wednesday, the 18th. So we'll review some more on Monday, kind of do a summation review on Tuesday, and then your test on Wednesday. All right, have a great weekend, guys. See you on Monday.